I'm gonna just begin the recording again. All right. So you got 97.0506. That is what you will get. Okay, so you can see that I have put a negative in front of the present value during the final computation. Why? Why did I do that? Why did I put a negative in front of the present calculation? Why did I say print round into bracket negative? Who can tell us why I did that? Well, here's the thing. The negative, remember, you're looking at the present value. So anytime you're looking at present value, it's something that is coming to you. Keep that in mind. It's coming to you. And if you don't put a negative, see, when something is coming to you, it's like it's a positive thing. When something is leaving you, it is a negative thing. But present value is coming to you. And because it's coming to you, it is going to be a negative. But you bring the negative here to make it positive. So the function would have returned a negative number, if you do the discounting from the future value to the present value, which simply means that you have to spend cash, of that 95. So by making it this, by putting the negative in front, but I want to go to the Python itself. By putting the negative in front, you are able to help yourself to get the value. So let me just write this and then run it. So that is 97.06. If you remove the negative, it will become negative 97.06. And it might look like, what is that? Why is it negative? Okay, so why is it negative? Now, another option is you can keep it like this, but rather put the negative to the future value. So you can see that the future value is 100. You can say that is future value because that one is leaving you. So if the future value is leaving you, you can put that as negative. The present value is coming to you. So in that case, you don't put a negative in front of the present value. Guys, do you understand what I mean? Go ahead with your question.
Doc, please. I was looking at the argument that the present value is taken in the slide. I realized in the Python here you introduced some when is equal to end. Can you please help me understand the role it plays?
Which one?
The syntax for the present value. I'll just matching it with what you shared on the PowerPoint, and I saw that you introduced some when is equal to end, END.
When it is equal to, on this same very question?
Yes, yes. I'm just looking at the argument that you for that is that the input that the present value takes on the slide compared
It
to
is
the code that you type
npf.pv,
here.
that one.
Please, the one in the slide doesn't have when, so I just wanted to find out the role that when is playing in the Jupyter notebook.
Okay, wait. I don't. So the Jupyter notebook, I have npv.pv, and you say you don't have the dot.
No, I mean in the formula that you shared on the slide number 9 for the present value, the argument that it takes.
Uh-huh.
When there's a last one that is you introduced called when. It's not on the PowerPoint that you said. So I was trying to find out what is the role of the when, the
Oh,
last argument.
okay, so that is the period. Okay, that is a period. Normally, we use that when we are dealing with multiple compounding and annuity. When we come there, you will see the use of it. Okay, normally it is either a start or an end. And when we come to multiple feature compounding, and then we come to the annuity, you get to know the real use of it. But for now, because we are not doing anything related to that, we'll set it up at the end value. When we have to set it at a start value or at a zero value, I will explain the meaning of that. But right now, when you see the nature of the question, of such questions, that is when you will appreciate it. But for now, you will not appreciate it even if I explain. Now let's see the question related to it. So Pele, do you understand?
Yes, Doc.
Yeah, but for any time you're calculating this present value and future value, you just, in fact, even if you remove that, okay, you'll still be able to calculate your activities. Okay, any other question? I want to believe that those of you who are not asking questions, whom I'm going to be asking questions very soon, okay, those of you who are not asking, the guy who just asked the question, what's the name?
Kingsford.
Yeah, Kingsford. I'm going to remove the when. Do you see my screen?
Yes, I can see your screen.
I just removed the when, and I'm going to run it again. You get the same thing. So the when is not useful here at this stage. And you can try it also on yours.
Okay.
All right, let's go to the trial number 2. What is the future value of 100 investment if interest is compounded annually at a rate of 5% for 3 years? Guys, I want you to calculate this within 2 minutes. Whoever is able to do that, you let me know. Whoever is able to do that, you let me know. Calculate that using your Python and let me know. You know, somebody is saying that, oh, my colleagues will calculate it, so I don't need to worry my head. Yeah. You don't need to worry your head. I am seeing the following people. First person to calculate is Eric Kumi, then Amanda, then James, then Frederick, then Monica Seto. These are the only smartest people I have in my class so far. Okay. They are those who have done that. The rest of you, you can copy their answers and also post the answers to make it look like you have also done it when you have not done it. You know, but your capacity to do this is what makes the difference. Okay. Now, for those of you who claim that you have calculated, I want you to do it in 4 decimal place and post your 4 decimal place for me to be sure that you actually done it. What is the future value? So if one day in the future, 3 years time, I want to collect $100, how much do I have to put in now to be able to? Now remember that for the value to be positive, the future value must be negative. Now why? Because we are looking for future. So the future value is going to be positive to us. And so if you check it carefully, FV is the one being used here. FV is the one being used here. And the PV is leaving you. Okay. It says, what is the future value of a present investment of $100? So that is leaving you, and that is why it was given a value of that. If you run this, you're going to get $115.79. If you round it to 4 decimal places, of course, the value will change to 7625. All of you who worked it without the help of anybody, see, the smart people are still doing the same thing. Monica, Samuel, Michael, Ruth, Frank. Man, these are the same old guys who are demonstrating readiness with me. Okay, fantastic. Let's go to the next one. Now we come to the example. Okay. The next one, it says, what is the present value of a deposit? If you see, watch the words, guys. It's not all the time you see the word present value, present value, present value. If you look at some of my questions, sometimes you see the question as not asking you for the word present value, but it's actually present value. What is the present value of the deposit? That's down here. The present value of the deposit, if you expect to earn 5,000 lump sum payment in 5 years' time, if the discount rate is 8.25%, what is the present value of the deposit? I wanted to calculate this in 2 minutes. Let me know. Calculate this in 2 minutes and let me know. And guys, if you don't understand, you ask, please. If you don't understand, ask. So I want to see, privately send me the answer. Okay. Those of you are sending the answers nicely. You are doing well. Privately send me the answer because I feel that some people might be copying what others have done and sending me when in reality. And by the way, sometimes you can command the Python to give you the answer in a sentence. In a sentence. I have Amanda being the first person to have privately sent me her answer. And boy, oh boy, is that correct? Is that correct? And my, oh my, that is correct. The first smartest answer, Amanda. Then you had, who followed? Samuel followed. Then James followed. Stephen, revise your answer. Okay. Minerva follows. Rosemary, check your answer. It's not correct. Joseph Harvey follows. Okay. Joseph Kingsley follows. Seto follows. AMD, your answer is not correct. Frank follows with the right answer. Okay. Gloria Amissimum follows. Frederick, I'm going to end the number when I get 20 people. Frederick follows. Ruth follows. Della follows. Samuel follows. Samuel Sari follows. All of these are under recording. They are under recorded evidence. So just so you know. And then you have Fatima Nelson following with a final answer. Okay, good. So these are the guys who are demonstrating clear financial maturity for this course. So how would you have calculated it? What is the present value of a deposit? That word, in fact, even if you have been asked, what is the value of a deposit if you expect to earn 5,000 lump sum? That statement alone, even if he has not used the word present value, you should know that he's asking you of the present value of a 5,000 lump sum. So how do you do that? This is how you do it. Okay. So on the screen here, you will see that this is how you execute it. So remember the interest rate is 0. So that's the rate. PV comes here. Blah. I have printed it as a statement. Okay. I've printed it as a statement. Okay. Remember the PMT is that the 5,000 is this. The 5,000 is something that you are going to get. It's a positive deal for you. But then the present value is taken out of money from you. So that's why you can see that I've put negative there. Okay. So you can write it as a sentence. And then once you execute it, let me run it. Okay. It says that the investment is worth $3,363.8 in today's dollars. Okay. So that 5,000 is worth 3,300 today. That is the present value of this basic. These are basic things that I'm using to wow you. As we go further, things are going to be much more, interesting. So it's very important that you're understanding the basic stuff as we go. Now let's do one more. Example is more efficacious than precept. So let's do one more. Yes, me.
Yes, Doc. So I was experimenting with the syntaxes. I realized that the example 2 and then the third one that we just did still return the answer without the argument, the when is equal to end. I couldn't relate that to what you said earlier.
He said it didn't give you the answer without a when.
It gave the answer without that argument.
Oh,
When
but
is
I
equal to
already
end.
answered somebody. Guys, did I answer that thing?
Yes.
Please explain it to him. I think he wasn't here.
I probably missed that.
Okay,
I
so
already answered that. That you can remove the when and the end, and you will still get the answer because it doesn't apply here.
Okay. Yeah.
And I
Thank
did
you.
it up here. Where is that? You see this one here? I did it here without a when. And we still got a 97.06. So, all right. Let's go to this example 2. Those first two were trials, but now we go to example 1 and 2. Example 2, what is the present value? What is the present value? And again, you would not always get the word present value. Just take note. That's a tricky part of some questions. What is the initial investment? That's how the question could be. What is the initial investment of an investment that leads to a total of 15,693 after 10 years of saving $100 every month? In fact, I can remove this thing so that it doesn't confuse. Okay. That's it. I think that by applying the dollar element is confusing. This is all right. So I wanted to again use, check this, use 2 minutes. I think this there is even 1 minute to be able to calculate this for us. What is the present value of an investment that leads to a total of $15,692.93 after 10 years of saving $100 every month? And assume the interest rate is 5% annually. But this time, watch it carefully. Compounded monthly. Okay, it's compounded monthly. So you are adding $100 each month. Let me see how you are able to understand this compounded monthly instead of all the ones you have been doing when the compounding was not monthly. Let me see the smart ones among them. First person was Samuel. Samuel. Guys, I'm getting some strange answers all of a sudden with this one. This is where wisdom is at its level. This is going to blow some people into pieces. So remember, we're looking for the present value. We're looking for the amount in today's dollars. Let me see. I'm not getting right answers at all for this. I'm not getting right answers at all for this. So I've got Minerva. I think she was the first person. Monica was the second correct person. Samuel, that is not correct. Eric, that is correct. Amanda is correct. Setawa is not correct. Michael Boachi is not correct. Stephen Kwesidako is not correct. Good. Joseph Harvey is not correct. Guys, I am getting so many not correct, which is good. It means that you're learning. You're learning. So some of you are switching the things wrongly. Remember, the compounding was not yearly. It was monthly. It was monthly. Okay. So take note of that. Remember, you're still calculating the present value. Okay, there's something you got to do with the number of period, the NPER. There's something you got to do. It's not straightforward there. There's also something you have to do with the payment. Remember the payment, because you were told that there's a payment of what? $100 every month. That was a saving. So that is something you are putting in every month. You are adding that every month. Apart from the 15,692 every other month. So the 15,692, okay, that is the future value you are getting. But every pay month you are putting in 100. So 100 is leaving you, okay, but the goal is to get that. So, and then the most important thing is that it's been compounded monthly. So there's something you got to do with the rate, and there's something you got to do with the number of period of compounding. That is where the trick is. That is where many of you are not getting this correct. Okay, Fatima is not correct. Joseph is not correct. Clifford is not correct. Samuel Atta is back. He's not correct. Della Akakpo, that is not correct, Della. Oh man, only 4 people have gotten it correct. That means some are really thinking. Nee, you are back, but that is not correct. Joseph, you are back. That is not correct. Eric Sapon is back, but that is not correct. Stephen, you are back. That is not correct. Frank has nailed it. Oh my goodness. Frank and Gloria Amison just nailed it. Ruth, that is not correct. Frederick, that is not correct. Fatima, that is not correct. Oh my goodness. Frank and Ruth just nailed it. Frank and Gloria just nailed it some few minutes ago. Smart. Okay, Fatima is back. That is not correct. Samuel is back. That is not correct. Michael is back. That is not correct. Michael, your value is so high. 26,000. Then I say, ooh, queen. That is so high. Remember, we are looking at present value. And remember, the future value was even 15,000. So obviously, the present value cannot be 15, more than 15,000. The future value itself you are expecting is what? Is 15. So how can you put something down and then you rather get something less? No, the present value should be way, 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 way less. And we are talking about 10 years time. So check it. Eric, that is not correct. Adjoa Sapoma, that is not correct. Frederick, that is not correct. Guys, come back again. Oh my goodness. Michael Inkum just nailed it, man. That's what I'm talking about. Fatima, you come back again. That is not correct. Michael just nailed it. Nee, that is not correct. Nee, you are back. Your value has reduced, but it's still not correct. Samuel, your value has reduced, but that is still not correct. Samuel, your value is not correct. It's still below 15,000, but that's not correct. So this is good. This is an indication that you guys are thinking. But now, guys, let's go back to the drawing board. Something is happening. Okay? So this one, I'll work it with you. Because what is happening right now tells me that I've got to work this with you. So the first thing, ideally, suppose you were starting this, you've not imported NumPy Financial. Okay? The first thing I would have done is that you would have imported NumPy Financial straight away like this. Now, get something right. We are going to calculate present value. So let's do PV. Okay, and that is equal to, and you are going to use the formula as always. So you write NPF PV. So NPF.PV. Okay, you bring your bracket. Inside a bracket, we are going to put down our rate. Now, you type your rate, RATE, equal to. Remember, the rate, the interest rate, watch the word. The interest rate is 5%. That is up here. But this interest rate was compounded monthly. And because the interest rate is, see, when we mention the interest rate and it's not compounded monthly, you don't divide by anything. But if it is compounded monthly, if you could remember, you divide it by 12. If it is compounded quarterly, you divide it by 4. If it is compounded half yearly, you divide it by 2. And if it is compounded annually, we don't say it, but you divide it by 1. So all the ones we've been doing, they are compounded annually. And that is why we have divided them by 1, but we didn't say that we divided them by 1. Now, if it is monthly, you divide it by 12. So you take this value, which is 0.05, 0.05, and then you divide that by what? 12. Oh, where's the division? Divide that by 12. That is the rate. So this is the part some of you are getting wrong, and you were not able to do that. So that's the rate. If you don't understand, please ask. Then you go to the number of period, NPER. Now, anytime you are doing something to the rate, it will affect also the number of periods. But you don't divide the number of periods by 12. You multiply by 12. Now, the number of period here is 10 years. 10 years. So keep this principle in mind. You're going to multiply that 10 years by the rate of compounding, the duration of compounding, which is 12. So you divide the rate by 12, if it is monthly compounding, and you multiply the period by 12, if it is monthly compounding. This is the main thing. Now, interestingly, for this very question, you were also told that you are putting in $500 every month, so which is the payment, the PMT. Okay, so now you go to that PMT, and it's equal to 100 because that's what you're doing. Okay? Previously, PMT had always been 0 because there was nothing that you were paying every month. Every month, the PMT is like the payment, the regular payment, the cash flow that you're always doing every month. We are told from here today, saving $100 every month. So that's what you are supposed to capture here. And now, once that is done, it leaves us with our future value. The future value was given to us. Okay, so everything is given directly to us. It's up here. It's 15, 6, blah, 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 $93. Okay. Now, future value is something you are going to collect in the future, so you will not want to make it minus, okay, because you're going to collect. Okay. But the present value is minus. So when we come to the final answer, we'll change the present value to minus. Of course, you can add the when, if you so choose, or you can decide not to add, no problem. Whichever way it is, do that. Now, what will be
the payment is also leaving us. Why are we not doing it -2?
Sorry, say that again. The payment is leaving us. It has to be minus. Sorry. The payment has to be minus. Yeah. Good. I actually deliberately left it there so that I can ask you.
Thank you.
Very good. That shows that you are really learning. So that is how it is supposed to be. So we are going to print our answer. So I can say that print blah, 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 print the investment is worth plus string. I put a string around the investment and make sure that my present value is negative. I correct it to decimal place, and I want the answer to be printed in today's dollars. So you run this, and it is $100. You see? And the answers you people are giving me, somebody was giving $22,000. But again, you just should tell you that it's not all Python knowledge. It is knowledge, life knowledge. Because if you are actually understanding the question, you will know that I am expecting to get $15,000 in 10 years' time. I am putting $100 down every month. But then I want to know how much I should put down now. So that in the future, I will benefit from that. So obviously, any amount, 10,000 will not work. Because every month you are putting in 100. And this is 10 years. So by a little bit of gumption, a little bit of thinking, you will come to realize that no, the only amount I have to put in for today, just today, is just that amount of $100. Of course, even if you know that it's not that $100, the amount should never be more than 15,000. So it is about understanding the compounding. The compounding is key. And also knowing that sometimes there are other things. It's not just what you put in. So sometimes a person can go and put a lump sum amount. And then after that lump sum amount, every other month you'll be adding some things. Or sometimes you just go and put in a lump sum amount. You don't add anything and wait. Okay. If you don't add anything every month, then this payment part will be gone. So the payment would have been zero. Okay. So the only thing that you're going to have, if you are not going to make $100, you see what you're going to get. This is what you're going to get. I think somebody gave me this answer. That means you are not adding $100 every month. Then it means that what you should put down one time is 9,000 for you to get a 15,000 in 10
No, I
years.
think I gave that answer. That was a mistake I made.
Aha, good. So that is good. It's good you are demonstrating that. The other bait, which apart from changing this, is where some people didn't take the division sign here because they forgot that when it is monthly. That's why I've made a monthly bold. Okay. If somebody had asked me why is it bold, I would have told you. The reason is because when it is compounded monthly, divide the rate by 12 and multiply the period by 12. It's not dividing both of them by 12. Take note of that. But when it is compounded quarterly, that is, you divide the rate by 4, you multiply the period by 4. When it is compounded semi-annually, see that is divided by 2, multiplied by 2. Okay, so this becomes your answer, $100. I think you are all cool. All right, let's go to the next one. Example is more efficacious than precedent. I'm giving you these things, and as we explain them, you'll be able to get the beef of the entire matter. All right, compute the present value of an investment. Okay, this is a little bit tricky too, but I know you can do it. Compute the present value of an investment which will yield, I could have simply said computer value of an investment, or what is the value of an investment that will yield at $10,000 in 15 years from now at an inflation rate of 3% per year, and assign it to an investment 3 and another with a horizon of only 10 years with an inflation rate. So there are two things you are calculating here. Okay. If I forget about this statement of assign it to an investment 3, because it's just a statement. Okay, so that just do that, and another with a time horizon. So the first time horizon is 15 years, but the second time horizon is not 15 years, it is 10 years. So you're going to do for both. And this one is easy. This one is easy because it carries the idea of a few of the ones that we have done. So this one is very easy, cool, easy. I should get the answers quickly. You must all remember, you are expecting to get what? $10,000 at the end of 15 years for one of them. And then at the end of 10 years for one of them. What will you get? I just need the first 5 smart answers. When you do for one, just copy it and paste for the other. And you print both. You get the results for both. Who is done? The first person to crack the code. Let me see. Samuel, you did one for me. I needed 2 answers. Clifford has given me both answers perfectly. That's the first perfect answer from Clifford. The guy is smart. The guy is ordained. That's good. That's good. Samuel also comes back. Samuel gives me the first answer correct, the second answer correct. Very good. Samuel is back.
Yeah.
Frank, I need your 2 answers, not 1. Monica gave me the first answer correct, the second answer correct. Excellent. Okay. Eric, he gave me the first correct, the second correct. Super. Frederick gave me the first correct, second correct. Excellent. Amanda gave me the first correct, second correct. Perfect. Minerva gave me first and second perfect answers. That's what I'm talking about. That is what these are the people you should befriend in the class. not the ones you have been befriending. These are the people you should take them to lunch and tell them, what do you want? Okay, Della, Akakpo, first and second answers, perfect, correct answers, executed. Okay. Mean, come back again. I need both first and second answers. James, Obeng, 64. And then, excellent. So now, let's go back to the answer. So if you want to work it, you work it like this. Again, we are looking for present value. So I call the first one PV3 and the second one PV4. Just that. You run it, and you should get these two answers as the final one. Again, the zero wasn't there. There was no compounding, nitty-gritties, nothing. So the coast was clear right here. Yeah. Any question? Now, there are other ways of calculating this compounding, but this one is a little bit not smooth. Look at this next question. What is the future value? Okay, I wanted to solve this. I shouldn't have given you the calculation, but at least I've given you. What is it? Because one is a simple interest, one is a compound interest. What is the future value of 10,000 held for 5 years in a savings account, just in a savings account with a 10% simple interest paid annually? What is the future value? Calculate that. Okay. I've given you some formula for that. And then what is the future value of 10,000 investment held for 5 years in a savings account with 10% compound interest? So this one is compound interest. That is why this formula has been given. In 2 minutes, let me see the smartest one. In 2 minutes. In 2 minutes. In 2 minutes. In 2 minutes. I want to see the smartest ones. Two minutes. Two minutes. Who's done? Only 2 people. Let's see. The first one, Ajwa. Oh, no, that's not correct. Ajwa has not done. Okay, wow. Monica. Monica, who is that brainchild? Man, Monica. That brainchild is something. Monica is the first person to crack my barrel of jewels. Minerva then followed. These 2 are the brain powers of the class. Note them, befriend them. Befriend Monica Seto Edu. Get to know her. That is if she is not copying things and Monica, I hope you are not copying things and doing ChatGPT activities.
Oh, no, sir.
Because if it is coming from your brain, it means that brain is golden. It's golden brain. Okay. And Minerva, that brain you have is an untouchable brain. These are the people you should befriend. Della Akakpo just cracked it as well. Okay. These are the people you should get to know. Okay. Eric Sampon gave me both answers correct. Perfect. Who's the next person? Who's the next future bionic person? Who is the next Einstein? See, these are where you get to know people who have already been blessed ahead of their season. Michael Lincoln cracked it already for me. That's it. Oh my goodness. Look, when you are doing the exam, you come to realize that it's the speed at which you do the thing that matters. It's the speed. Okay, that is why ChatGPT will not be able to help you. Because the nature of the question are in such a way that ChatGPT will not understand. It's not like this. It's your clear understanding. You know, so it's important. I want you to check your answers again, Ruth and Frederick. Check your answer, Frederick. One of your answers is not correct, Frederick. Clifford, you have perfect answers. Perfect answers, Clifford. You are back in the game. Okay, this one you delayed a bit, but you're back. You're back, which is good. Sometimes it's good to delay, but when you're back, it's back. Good. So let's see the answer to this. The simple interest is very simple. Okay. This is it. I just want to, as whilst you were doing now, I was calculating this thing also somewhat. So the simple interest, if you do that, this is what you get, 15,000. Okay. And then a compound interest, you get 16,000. Guys, what does this tell you? Who can tell me? What does this tell you practically? What does this tell you? What does this tell you? You know, a lot of people do simple interest savings. Because that one you can just go and take it anytime, isn't it? So whenever you want to take it, just come and take it. Whenever you want to take it, you just come and take it. But then the compound interest, it means that whatever interest you get is added to the original principal. And that is also compounded in addition to it. Okay. Everything we've done up to this time is just a single cash flow. But now I want to look at multiple cash flows. Multiple cash flows. We are getting towards the end of our basic work today. Multiple cash flows. How do you execute it? Now, in terms of multiple cash flows, okay, we are going to work with the present and future value scenarios with multiple cash flows. We are going to create pandas data frame and assign variables to them. And then we'll use a formula written with these variables. So this is where you are not just relying on NumPy financials alone to do the work for you, but this time you are writing the code, you know, because sometimes you got to learn a bit of how to write them yourself. So let's take an example. Assuming a cash flow is 30,000 Ghana cedis, you have another 40,000 Ghana cedis, you have another 50,000 Ghana cedis over a 3-year period, with each amount occurring at the end of the period. So at the end of the first year, you have a cash flow of 30,000. At the end of the second year, you have another cash flow. At the end of the third year, you have another cash flow. Okay. What is the present value of these cash flows, given that you have an interest rate of 25%? This is similar to the one that I did. Okay. Now, this is the present value of multiple cash flows. And so the way you calculate it should be, the present value should be the present value of the sum of the cash flows. That's the key. The present value of the sum of the cash flows. This is what we mean by an ordinary cash flows. Ordinary cash flows. There are two ways of doing this. Let's look at the first way. The first way of doing this is you first import pandas. Let me look at the time to see whether, okay, let me just show you, because I think that this might take a bit of time. So I will just write it and rather demonstrate it for you. So you can't take that. Well, one thing you can do is that you can use the present value formula that we did and do it one by one, isn't it? And then when you finish, you add them. Or you can use this formula. So you create a cash flow. We are creating our own definition formula. So we call this one cash flow or CF, whichever way you want to go. And then we put all of the different cash flows together to define the cash flows. We created a discount rate. We're told that the interest rate is 25%. So you can create this as 25%. Look, everything I'm doing here, you can change it. You can change this one and call it CFS, cash flows. The discount rate, you can just call it DR, okay, for discount rate. And then we can now use this formula to calculate the present value of all of them, of all the future cash flows. So we use the present value of all of these future cash flows. And this discount rate, I called it DR. So watch the formula carefully. The formula is the sum of the cash flows divided by 1 plus the interest rate. Okay. And you put the cash flows here. But here is the interesting bit. I have exponentiated, okay, raised to the power. Okay, this is how you write it in Python, okay, with this double sign. Okay. So that double sign will exponentiate this value in the time period for each cash flow. Okay, and then we'll define it for each of the cash flows. And you can see that I've put the I there. Okay, the I is index based, so you start from 0, as you know, when you are doing exponentiation, you start from 0. Okay. But we are going to start from, in this case, we are going to do 1, 2, and 3 because there's no period, 0 period in that regard. So this is how you put all of the cash flows together, and then you can easily print out the result. Okay. And this result will indicate that the present value of all those cash flows is going to be 75,200. This is a direct one. Or you can do the first one that we did. You can do it 1 by 1, 1 by 1, 1 by 1. Okay. And when you finish, you add all of them. So that is one approach of doing this. Another approach is you can even do a cumulative version of each one. So this is another one that I've done. Okay. The same thing, you can define the interest rate, define the cash flow, but you want to create a data frame for the cash flow. In fact, if I go back here and I take this one, okay, and I just show you this, and I just type just cash flow here, and I run this, it will just give you a data frame of the cash flow. So that's what I've just done. I've created a data frame for the cash flow. Let me undo this. Okay. Then I will now create the cash flow of the present value. So I'm creating a formula that will pick the cash flow of each of them. Remember, this is the definition, and I'm creating a present value of each of them. I create a table of the present value, and then I create a table of the cumulative cash flows. Okay, and then I can now add all of them together using this final table. I can even concatenate to the original table, the data frame with the total one, and then come out with a beautiful, result so that everything is accumulating. So with this one, you are able to get the cash flows in the table, the present value for each one, the one I said you can do it for each one. And then when you finish, you sum all of them. This is a total that we had, which is the same as the one that we had. So if you want to see what is the present value of each cash flow, you will see it as you move. And then finally, you add all the present values together. Now, so that is multiple cash flows. Don't forget. Okay, so when you have one cash flow, it's a whole new thing. But when you have multiple cash flows, that is a different thing. Now, what is the present value given the interest rate is 30%? The same thing. If the interest rate here was 25%, when you increase the interest rate, what do you think will happen? Who can tell me? Who can tell me? Suppose we had increased the interest, we are not calculating. What will happen? If we increase the interest rate, what will be the total net present value? The current one is 75,000. What will happen? Will it come down or go up? With a 30%. I need an answer. Will it come down or go up? Michael, you asked a question, eh? Oh, now you can put your question in the page for everybody to know. He said, do we have a compound interest savings in Ghana? Yes, we do. We do, Michael. What do you think will happen if the interest rate goes up? What's the name? Minerva. What will happen?
I think it would increase, it will go up.
So the 75,000 will go up, right?
Yes, please.
Exactly. Let's do that. I'll just replace the whole thing. And that is the amount. It's got to 86,000. In fact, when I was giving some incomes to my bullion lady, I told her that I want a higher interest rate. So I remember she gave me an interest rate of 23%. I said, no way. Then
this one is 69.
No, that's, oh, is it 69?
Yes. We didn't round the answer.
Okay, hold on. Let me see. Let me be sure. For each one of them. Yeah, 69,503.
Yes.
So cumulatively, what are we calculating?
So I was surprised when you said to go up because we are looking at present value.
Present
So
value.
if
Of course,
you are looking at present value, it should
it
go
is come
down.
down.
If you
Yes,
are looking at
it
future
should be up.
value, it would have gone up.
Yeah.
Therefore,
Yes, Doc. I was about to say the same thing because this time around we are discounting the
We're discounting.
future value more heavily by an extra 5% compared to the 25.
let's see. So you want more money, eh? It should come down. It should come down.
Yes, Doc, and that's what we have. It was 75. It has now come down to 60.
What they want to do is they want to get a reason why it's come down.
So because we are discounting at a higher rate.
Exactly. Somebody asked something. I'm trying to see who asked that. Says because somebody has put it in the chat that he's expecting that. He says the thing come down. The way it's put it, the thing come down. It's like he wants but you are discounting it at a higher rate, so that is why it should come down. So the point is that try and get reasons behind the work you're doing. But for some reason, some of you probably have not done investments before. And so because you've not done investment before, so some of these things will be the first time. Of course, Myers' book will give most of this. But here is the thing, increasing the rate will reduce the present value. Keep that in mind. Increasing the rate will reduce the present value. Yes, because you want a more future value. Okay, you want a more future value, so the present value will come down. Okay, maybe you are mixing it with the future value, but you want the future value is going to go up, but the present value will come down. That's the key. And of course, if you decrease the rate, what do you think will happen? It will increase the present value. If you decrease the rate, it will increase the present value as well. So if I were to pick this one, I'll copy this same one. Okay, come down here, change the interest rate because it says it's 20%, change it to 0.2 here and run it. You see, the present value has gone up because we have reduced the interest rate. Yeah, that's it. I even have that conclusion here. Okay, what happens when we change the rate to 15? All of that. So that's it. That's it. Increasing the rate to reduce. I want us to now to go back to the slides and conclude. We have looked at all of these in your slides there as well. And now we want to bring a conclusion to our applications and the importance of present value. Now, please note, you just looked at present and future value. You can also do all of the other ones. So you can calculate the rate, you can do change of subject and find each one of them. But the key point is that when you put it into Python, it can do all of them. Okay, I want to know how long it will take me before I'll get this money. Somebody will say, no, I don't want to know how long it will take me. Just tell me how much I'd rather get. Okay. Or somebody says, I don't need to know how much I'd rather get. Tell me how much I would rather put in. Okay, and things like that. It's very practical. Why? Because a good business will generate income every year. But it will usually need an upfront investment with something they call startup capital. If you want to determine whether the business is worth starting, I run businesses, and the first business I decided to do, okay, I put in an amount of 680 Ghana cedis. And that was what I was putting in. That was all my expenses, guys. And that business, 680 Ghana cedis every month, that was what I was putting into my business. And every single month, after 1 year, I was making an income of $8,000 per month. With a business, I was putting only 680 Ghana cedis. So that should tell you $8,000, not cedis, dollars. Okay. My second one here, and this is application. My second one, I put in an amount of $120 every year, not every month, every year, and making between $5,000 to $10,000 every month. So if you have an understanding, that's why some people put in money into businesses and it doesn't work, because they do not have. Don't put in more than 5,000 Ghana cedis into any business, guys. That's my advice for you. Unless that money, you can get it 20 times if somebody should ask you. The worst is to go and borrow money to start a business. Never do that. Anyway, that's for another. If you want to determine whether the business is worth, the present value of the income it generates should be compared to the cost of the investment. Let's take another one, master's degree. Why are you putting in that money into your master's degree? You got to sit down and calculate the present value of that money. In fact, I did this thing with a lady in Canada, and then she got to know that she doesn't even have to do that study, because the amount of the mental torture that is going to go through compared with what that money would have. So sometimes you got to take present value analysis before you know whether to go into it. But sometimes, because of the repetitive return after you finished, that is also the reason why you want to put in money now. So if you want to determine whether it's financially viable, you compare the tuition cost of the present value of the increase in the future earnings. But the question is, when will your future earnings be increased? There are some EMBA students that after 6 years, of doing the EMBA, his income was still Oshioko. He came to me and asked me that, so Doc, what was the essence of the EMBA? I said, the essence is your essence. Another thing is asset valuation. You can use present value analysis to look. In subsequent times, you are going to do a lot of practical application of present value on running a business and even capital budgeting. That is where I show you practically how someone who is earning 3,000 can become a millionaire. Determine if a financial asset or a stock or a bond is worth. For example, I will not even do a savings in the UK. Yeah, I will not. I'd rather do it in Ghana.
Why?
Oh, there are beautiful reasons why. I will not buy bonds here in the UK. I will not buy treasury bills. I will not buy. I will not. And many people don't. Those who understand the market system, they will not. Do you know the rate? The maximum rate you will get is 5%. I got a house, build that house. So when you go into property, it's a different ballgame. That's for another day. But there's one you can do, a mutual fund, a particular mutual fund that I do here. That is into Alphabet, Google, okay, Tesla, and some other things. Those ones are great. Okay, those ones are great. And those ones, it took me some time before I got to know about them again. 19%. You will not get that here in the UK. 19%? No way. It's like the one I did in Ghana, 27%. People tell me, how on earth? Somebody was just asking me, how could you do 27%? Again, you got to do valuation. So by the time each of my two cases, by the time each of them is 14 and 15 years, both of them are millionaires. Simply because of this knowledge. I keep saying that wisdom is the ability to see what is obvious, even when it's a secret. Asset valuation. Look at that. Compare the price to the present value of the promised payment. So present value is very, very important. Ladies and gentlemen, that brings us to the end of the entire
Entire Kabugo.